In this quiet space of Dreamtime Science, we turn down the volume of the universe to hear its subtlest secrets. Let's explore the cosmos at the perfect pace for peaceful contemplation. You know, I've been thinking about the shape of the universe lately, and there's something quietly remarkable about how space itself might curve or stretch in ways we can barely imagine. It's not just about stars and galaxies floating out there. It's about the very fabric of everything around us, and I can't wait to share some gentle ideas about what that might really look like. It's like a cosmic bedtime story, but one that makes you wonder how big and beautifully mysterious our home truly is. If this peaceful blend of science and serenity helps ease your evening, consider joining our community of gentle learners. Share your favorite moment of scientific awe in the comments. First, let's create the perfect space for learning. Cocoon yourself in comfort, release any lingering tension, and let your breath become soft and steady. If you lie on your back beneath a clear night sky, far from the city's persistent glow, the sky unfolds as an ancient tapestry, stitched with 1,000 flickering points of light. There, the universe presents itself not as a concept, but as an experience, silent, boundless, and implacably mysterious. The darkness above is not merely an absence of color, but a presence, a vast, enveloping mystery that has drawn human minds upward since before the written word. It is here, in the hush between heartbeats and the chill of dew settling on grass, that curiosity about the cosmos stirs most potently. Perhaps you have felt it yourself, a question, at first unformed, rising from somewhere deep. What is this place, this dome above, this endless expanse? Does it go on forever, or does it twist back upon itself like a serpent swallowing its own tail? Is the universe flat as a painter's canvas, or curved and folded in ways that would bewilder even the most agile imagination? Such questions are not merely scientific, they are existential, wove into the stories of cultures and civilizations, whispered around fires and etched into the bones of ancient monuments. Long before telescopes or satellites, the night sky was a living myth. The Greeks called it the firmament, imagining it as a crystalline sphere encasing the world, with the stars as jewels fixed upon its inner surface. The Babylonians charted wandering planets and built ziggurats to observe their dance, tracing shapes and patterns in the heavens, reading omens in their motions. The Egyptians too looked up and saw the goddess Nut arching over the world, her body studded with stars, her long arms and legs touching the horizon at 4 sacred points. To them, the sky was not a void, but an entity, a ceiling painted by divine hands. But what shape did these ancients assign to the world itself, wrapped within this celestial shell? For many, the earth was a disk, a flat expanse floating atop primordial waters, encircled by a ring of mountains or a serpent of infinite length. The Norse imagined the cosmos as an immense tree, Yggdrasil, whose branches and roots cradled worlds within worlds. In the Hindu tradition, the universe balanced on the backs of elephants, who themselves stood atop a cosmic turtle drifting through endless sea. Each myth, in its way, sought to anchor humanity within the infinite, to give form to the formless and boundary to the boundless. As centuries passed and cultures flourished, the shape of the universe remained a tantalizing enigma, refracted through philosophy and nascent science. The Greeks, with their penchant for geometry and order, began to probe the cosmos not just with stories, but with reason. Pythagoras and his followers, enchanted by the harmony of numbers, imagined a universe composed of perfect spheres and circles. Plato, in his Timaeus, described the heavens as the handiwork of a divine craftsman, arranging the stars in precise mathematical orbits. Aristotle envisioned a cosmos layered like an onion, with the earth at its immovable heart, encased by concentric crystalline spheres that bore the Sun, the Moon, and the planets. For nearly 2,000 years this geocentric vision would endure, so compelling in its symmetry and so aligned with the evidence available to the naked eye. Yet even as these early models imposed order upon chaos, the question of the universe's ultimate shape persisted. Was it truly infinite, stretching beyond comprehension, or was it finite, bounded by the outermost sphere? If it had an edge, what lay beyond? Aristotle himself struggled with the notion of infinity, treating it more as a potentiality than an actuality, a thing that could never be completed or contained. The philosopher Lucretius, centuries later, would urge his readers to imagine hurling a spear at the rim of the universe. If it passed beyond, then the cosmos could not be bounded. If it bounced back, then there must be something beyond the edge to halt its flight. In this way, the mind circled restlessly around the contours of the cosmos, chasing its own tail through paradox and wonder. As the medieval ages deepened, Christian cosmology layered new meanings onto old frameworks. The universe became a moral order as well as a spatial one, with heaven above, hell below, and the earth at the center of God's design. The celestial spheres were no longer merely geometric, but spiritual, each one inhabited by angels and governed by divine laws. The shape of the universe was not just a matter of physics, but of faith, inscribed in cathedral ceilings and illuminated manuscripts. To question its structure was, in some times and places, to question the order of creation itself. But the stars, indifferent to dogma, continued their slow procession across the sky. And as the Renaissance dawned, a new curiosity bloomed, one that dared to look beyond the received wisdom of ages. Copernicus, with quiet audacity, placed the sun at the center and set the earth spinning in its wake. Galileo, peering through his telescope, saw the moons of Jupiter and the craters of the moon, and realized that the heavens were not immutable perfection, but worlds among worlds. Kepler found that orbits were not circles but ellipses, and that the music of the spheres was more intricate than anyone had guessed. With these revelations came a profound shift. The universe was no longer a closed, harmonious shell, but an open expanse, teeming with motion and possibility. The question of its shape became more pressing and more perplexing than ever. If the Earth was merely one planet among many, and the Sun just another star, what then of the boundaries? Was there a wall at the edge of the universe, or did it stretch on without limit? Could one, in principle, travel outward forever, never reaching a terminus, always chasing horizons that receded into the night? It is here, in this swelling sense of scale, that the imagination of science fiction begins to stir. For as long as humans have looked up and wondered, they have also spun stories that leap beyond the constraints of known reality, exploring not just what is, but what might be. In the pages of pulp magazines and the flicker of silver screens, the universe takes on shapes both familiar and strange. Spaceships soar through star fields unbounded, wormholes knit distant corners of the cosmos together, and alternate realities bloom like flowers in the dark. Think of the great speculative visions, the hyperspace jumps of Isaac Asimov's Foundation, folding space like a sheet of paper, the ring-shaped world of Larry Niven, an artificial habitat encircling a star, the galactic spirals of Star Wars, where empires rise and fall across a million suns. Each of these stories, in its own way, wrestles with the same questions that haunted the ancients. What does it mean for the universe to have a shape? Can space be bent, warped, or looped back upon itself? Is there an edge, a boundary, a final frontier, or is the journey itself endless? Our modern science, too, has not forsaken the poetic. The discoveries of the 20th and 21st centuries have only deepened the mystery, even as they have replaced myth with mathematics. Einstein's theory of general relativity revealed that space and time are not rigid backdrops, but dynamic fabrics, curving and flexing in response to mass and energy. The universe, in this vision, is not a static stage, but a living canvas, one that can be stretched, compressed, and twisted into forms that defy ordinary intuition. The shape of the universe we now understand is not a matter of geometry alone, but of topology, the study of how spaces can be connected, folded, and transformed. Is the cosmos flat, open, or closed? Does it possess extra dimensions curled up beyond our perception? Could it be finite yet unbounded, like the surface of a sphere, where one can travel endlessly without ever encountering an edge? Or might it be more like a donut, a torus, where a journey in one direction eventually loops back to the starting point through an unseen path? These are questions that science fiction has feasted upon, but they are also the province of cosmology, that most ambitious of sciences. Astronomers map the cosmic microwave background, the afterglow of the Big Bang, seeking subtle clues to the curvature of space. Mathematicians contemplate exotic manifolds, spaces where the rules of Euclidean geometry dissolve into something stranger and more beautiful. Physicists debate the fate of the universe. Will it expand forever, contract back upon itself, or reach a mysterious equilibrium balanced on the knife edge between infinity and closure? And yet, for all our instruments and equations, the experience of the universe remains irreducibly personal. To step outside on a cold night, to see the stars wheel overhead in silent procession, is to encounter the same questions that haunted our ancestors. The shape of the universe is not merely a matter of measurement, but a source of wonder, a riddle whispered by the void, inviting us to imagine, to explore, to dream. Consider this. Even now, with all our scientific advances, we are still tracing the outlines of a mystery. The observable universe, the limit of what we can see, constrained by the speed of light and the age of the cosmos, is itself a kind of horizon, an ever-expanding bubble whose edge recedes as we look outward. Beyond that, who can say? Perhaps the universe extends on, a boundless expanse dotted with galaxies, like islands in a cosmic sea. Or perhaps, in some unfathomable way, it wraps back upon itself, so that a beam of light, given infinite time, might one day return to its point of origin, carrying news of its journey to the farthest edge and back. Such musings are not idle. They shape the way we see ourselves, our place in the vastness, our relationship to the unknown. They inspire art and literature, science and philosophy, faith and skepticism. They drive spacecraft to the edges of our solar system and send telescopes questing into the heart of distant galaxies. They remind us that, for all our knowledge, we are still children of the stars, gazing upward in search of home. In the end, perhaps the most profound aspect of the cosmic canvas is not its shape, but its invitation, to wonder, to question, to seek. Each generation adds its own brushstrokes to the great painting, layering new insights atop old myths, weaving science and story into a tapestry that is at once personal and universal. The universe in all its inscrutable vastness remains a canvas upon which we project our hopes, our fears, our longing for meaning. And so, as the night deepens and the stars burn steadily above, the question lingers: what is the shape of the universe? Is it a flat plain, an endless ocean, a cosmic sphere, a looping torus, or something stranger still? Does it possess edges, or is it forever without bound? The answer, if it exists, lies somewhere out there, within the darkness, within the light, within the restless curiosity that stirs the heart to look up and ask. The journey toward understanding has scarcely begun, and the cosmic canvas awaits its next explorer, its next question, its next dream. As the hush of the universe settles around you, let your thoughts drift outward, across the infinite, the imagined, and the unknown. For in the search for the universe's shape, we find not only the contours of space, but the contours of ourselves, a mirror held up to the night, reflecting wonder without end. And somewhere, just beyond the reach of certainty, the first hints of the scientific method begin to flicker. Tools and techniques that will, in time, allow curious minds to probe the cosmic canvas with new precision, to measure and map the very fabric of reality. But for now the question remains, as luminous and elusive as the stars themselves, calling us ever onward into the dark. To peer beyond the observable, to contemplate the very shape of the universe, is to stand at the edge of what is knowable and gaze into the mist. For all the brilliance of our telescopes, for all the subtlety of our mathematics, we remain creatures of a cosmic island, adrift on a sea whose farthest shores we can only imagine. Yet it is precisely here, in the interplay between what we can see and what we yearn to know, that some of the most profound mysteries and wonders of science reside. Let us begin, then, with the horizon itself, the cosmic limit enforced by the speed of light, that most stringent of universal speed limits. Light, ancient and tireless, has been streaming across the universe since the first moments after the Big Bang. And yet, because the universe has a finite age, some 13.8 billion years, there is a boundary to how far any light can have travelled since time began. This boundary is not simply a sphere centered on the Earth, but rather a sphere centered on every observer anywhere in the universe. Astronomers call it the observable universe. Within this vast sphere we see galaxies, nebulae, and the faint afterglow of creation itself, the cosmic microwave background, a whisper of ancient photons set free when the universe was only a few 100,000 years old. But beyond that, beyond the most distant galaxies whose light only now reaches us, there may be more, much more, universe. Here our knowledge dims, our instruments falter, and our equations become less certain. It is a lesson in humility. Even as we map the cosmic web with ever-growing precision, plotting the luminous filaments of galaxies sprawling across unimaginable gulfs, we cannot say where, if anywhere, the universe ends. We cannot even say, with certainty, whether it is finite or infinite. For all the grandeur of our maps, we are explorers with lanterns, ringed by darkness. The question of the universe's shape, then, is not simply a matter of geometry. It is a matter of what lies beyond what we can see, and of how the structure beneath all things might extend, or curve, or even wrap back on itself in ways our senses cannot directly apprehend. Consider for a moment the very notion of shape on the grandest scales. In the familiar world, shapes are measured by rulers and compasses. A sphere, a cube, a saddle, all are objects whose geometry is determined by the way lines, angles, and surfaces relate to one another. But the universe, as described by Einstein's general theory of relativity, is not embedded in a higher dimensional space in the way a ball rests in a box. Instead, space itself is dynamic, malleable, and curved by the very presence of matter and energy. The shape of the universe is not the shape of an object within space, but the shape of space itself. To probe this, cosmologists speak of curvature. If the universe is flat, then parallel lines remain parallel, the rules of Euclidean geometry prevail, and the angles of a triangle always add up to 180 degrees. If, instead, the universe curves positively, like the surface of a sphere, then parallel lines may eventually meet, and triangles sum to more than 180 degrees. Or the universe could be negatively curved, like a saddle, where triangles fall short of that familiar sum and parallel lines diverge. Measuring such curvature is a task of exquisite subtlety. It is not something we can do with tape measures or protractors, not on these scales. Instead, we look to the sky, to the light that has travelled for billions of years, and to the patterns imprinted upon it by the early universe. The cosmic microwave background, for instance, offers a kind of snapshot, an image of the universe when it was very young, still glowing from the heat of its own birth. Within this faint glow, there are tiny fluctuations, minuscule variations in temperature, just a few parts in 100,000, imprinted by the primordial ripples that would one day give rise to galaxies and clusters. By carefully studying these patterns, by comparing the apparent size of known features at known distances, cosmologists attempt to infer the global geometry of space. And yet, here we encounter the first of many limitations. For all the precision of our measurements, we are constrained by what lies inside our cosmic horizon. We only see a patch of the universe, vast beyond comprehension, yes, but still a patch, like a stretch of road visible through a car's headlights on a foggy night. The universe could be perfectly flat in this patch, but curve gently or warp dramatically beyond, in ways we can never directly observe. In principle, the universe could be finite but unbounded, like the surface of a sphere. Imagine walking in a straight line on the Earth, heading east. You never encounter a wall or an edge. You simply circle the globe and return to your starting point. The surface is finite, yet there is no boundary. Could space itself be like this, but in 3 dimensions? Could you, in theory, travel far enough in a straight line and eventually return to your starting point, perhaps from the other side, though you would need to traverse distances so vast that even light could not complete the journey within the age of the cosmos? Or perhaps the universe is infinite, endless in all directions, expanding forever, its tapestry of galaxies stretching on without limit. In such a cosmos, every patch of space is much like any other. There is no center, no edge, no special vantage point. Space simply is, extending without bound. Yet even here, subtlety intrudes. For the observable universe, though mind-bogglingly large, is still finite. We can only infer, never prove, the nature of what lies beyond our sight. The universe could be infinite, or it could be a vast but finite manifold, wrapped in such a way that our senses and instruments are forever too limited to detect the twist. The cosmic horizon is both a window and a wall. There are further complexities yet. The shape of the universe is not simply a question of geometry, but also of topology, the deeper connectivity of space. Imagine, if you will, a video game world, one in which stepping off the right edge of the screen brings you back on the left. Inhabitants of such a world might believe space to be infinite, yet in reality it is finite, curled up upon itself. Could our universe be similarly wrapped? Could there be paths through space that loop back onto themselves, so that light, given enough time, would return to its origin by a circuitous route, like a cosmic echo, a whisper from the distant past? Mathematicians and cosmologists have devised a dazzling array of possible topologies, each strange and beautiful in its own way. There are 3 tori, shaped like the higher dimensional analogue of a donut, and more exotic constructions, spaces with multiple connections, crosscaps and handles, each producing a subtly different pattern in the distribution of cosmic structure. Some of these possibilities might, in principle, leave detectable imprints, ghostly patterns, repeated structures, or echoes in the cosmic microwave background. Yet so far, our searches have yielded no definitive sign. The challenge is compounded by the expansion of space itself. As the universe grows larger, the scale of what is observable changes. Light from the earliest moments is stretched, its wavelengths elongated by the relentless swelling of space. Structures that were once close together grow farther apart, and the cosmic horizon recedes ever outward, revealing new vistas, but always keeping the most distant regions forever beyond reach. Moreover, our own vantage point is not a privileged one. We are not at the center of anything. The observable universe is centered on us only because we are here to observe it. Every observer, wherever they may be, sees their own horizon, their own cosmic bubble. The true shape and extent of the universe must be the same everywhere, but each inhabitant can only glimpse a tiny fraction. There are, too, the practical barriers of observation. The faintest, most distant galaxies are shrouded in darkness, their light stretched beyond the reach of our instruments. Foregrounds, dust, gas, the glare of nearer stars, obscure and confuse our measurements. Even the cosmic microwave background, that most pristine of signals, is mottled with noise from our own galaxy, from the aftershocks of cosmic events, from the imperfect sensitivities of our detectors. And so we build ever more sensitive telescopes, ever more ingenious experiments, striving to peer just a little farther, to measure just a little more precisely. We launch satellites above the blurring atmosphere, float balloons to the edge of space, bury detectors deep underground to escape the noise of cosmic rays. Each new observation brings us closer, and yet the horizon always recedes. The limitations are not only practical, but also theoretical. Our best models rest upon assumptions of homogeneity, of isotropy, of the universality of physical laws. We assume, for instance, that the cosmos is much the same everywhere on the largest scales, that the laws of physics are unchanging across the eons and the light years. These assumptions are reasonable, supported by observation, but they are not proven in any ultimate sense. If the universe is larger than the observable patch, how can we know that its properties do not change, that its shape does not twist or warp in ways we cannot imagine? There are also the riddles posed by dark matter and dark energy, mysterious substances that dominate the mass-energy content of the cosmos, yet remain invisible to our eyes. Their exact nature is unknown, their effects inferred only from their gravitational pull and their influence on the expansion of space. They shape the growth of structure, the bending of light, the fate of the universe itself, and yet they are, for now, only shadows in our equations. Even the concept of expansion is subtle. It is not that galaxies move through space, but that space itself stretches, carrying galaxies along as if they were dots painted on the surface of an inflating balloon. The distances between unbound objects grow, not because they are flying apart, but because the very fabric of space is changing. This raises philosophical questions as well as scientific ones. What does it mean to speak of the size of the universe if space itself is not fixed but ever-changing? What lies beyond the expanding frontiers? Is there an outside to the universe, or is it all there is? In this intricate web of limitations, of horizons, of observational barriers, of theoretical uncertainties, our understanding of the universe's shape is necessarily incomplete. We are like mariners charting the coastline in fog, glimpsing promontories and inlets, but never the full extent of the land. We construct models, test hypotheses, seek patterns, but the totality of reality may remain forever partly hidden. Yet this very incompleteness is its own kind of beauty. It reminds us that science is not the cataloguing of certainties, but the pursuit of ever deeper questions. Each answer opens new mysteries, each measurement reveals deeper complexity. As the night deepens and you drift towards sleep, imagine the vastness that lies beyond the edge of sight, the unseen continents of the cosmos, the realms forever just out of reach. Somewhere beyond the most distant galaxies, the universe continues, perhaps infinite, perhaps curved back upon itself, perhaps shaped in ways stranger than we can conceive. In the darkness, the questions linger, unresolved, beckoning us onward. And in their gentle persistence, they prepare us for the next stage of our journey, a journey into the forces and laws that shape the universe's fate, and the hidden symmetries that bind all things together. The darkness above us is not merely empty, nor is it silent. It is a record, an archive of ancient light, a tapestry woven from photons that have travelled across unfathomable distances, bearing the marks of their passage and the secrets of the space through which they came. To understand the universe's shape, its geometry and extent, is to read this record with care and with the right tools. Tonight, let us drift together along the storied path of cosmic cartography and survey the delicate instruments, the ingenious ideas, and the relentless curiosity that have allowed us to chart the universe's contours. In the earliest epochs of human wonder, the sky seemed an upturned bowl, its stars affixed like jewels to a vault that arched over the earth. This was a kind of geometry, a cosmos finite, domed, and close at hand. Yet even then, some noticed the subtle clues that hinted at a more complex reality. The Greeks, with their love of measurement and pure reason, devised tools of geometry and logic. Eratosthenes, in the 3rd century BCE, used the simplest of instruments, a stick and its shadow, to estimate the Earth's circumference. He compared the length of shadows cast in Cyane and Alexandria at noon on the summer solstice, reasoning from the difference in angle and the known distance between the cities. The result, astoundingly close to the modern value, was a triumph of deduction and a first small step in mapping the world and, by extension, the cosmos. But beyond the Earth the stakes grew larger, the distances vaster, and the tools subtler. When astronomers sought to measure the distance to the moon, they watched eclipses and timed occultations. To reach out to the planets, they turned to parallax, the apparent shift in position of an object when viewed from two different places. Early astronomers, such as Aristarchus, attempted to gauge the distance to the Sun by observing the angle between the Sun and the Moon during half-moon. Their methods were ingenious, but the limitations of the naked eye and crude instruments kept the cosmos tantalizingly out of reach. It was with the advent of the telescope that the universe began to yield its dimensions. Galileo's device, barely more than a spyglass, revealed the moons of Jupiter and the phases of Venus, evidence that the Earth was not the center of all things. But it also allowed for more precise measurements of stellar positions. As telescopes grew, so did our reach. In the 19th century, Friedrich Bessel used a heliometer, an instrument designed to split and measure the angle between two stars, to detect the tiny parallax shift of the star 61 Cygni as Earth orbited the Sun. The angle was minuscule, less than a second of arc, but from it Bessel calculated the distance, over 10 light-years. For the first time, humanity had measured the depth of the cosmic ocean, not merely its breadth, yet distance alone could not reveal the shape of the universe. For that, we needed to understand not only how far, but also how space itself was curved and stretched by gravity, as Einstein would later show. The geometry of the universe, whether it was flat, open, or closed, would be written in the way light travelled across it, and in the large-scale patterns formed by galaxies and the cosmic microwave background. To read these patterns, astronomers required new tools. The night sky became a laboratory, and the heavens a map, if only the right markers could be found. Consider the standard candle, a concept as elegant as it is powerful. If one could find an object whose intrinsic brightness was known, then by comparing how bright it appeared from Earth, its distance could be inferred. Cepheid variable stars, first characterized by Henrietta Swan Leavitt in the early 20th century, provided just such cosmic beacons. Leavitt, working with stacks of photographic plates, noticed that the brighter Cepheids had longer periods of variation. This period luminosity relationship transformed these stars into cosmic yardsticks. Edwin Hubble, wielding the 100-inch Hooker telescope atop Mount Wilson, used Cepheids to measure distances to spiral nebulae, and discovered that these fuzzy patches were not clouds within our galaxy, but galaxies in their own right, each a separate island universe. The scale of the cosmos was suddenly vast beyond imagination, and its shape, its very curvature, an open question. Yet to answer it, we needed to look deeper still. The next instrument in the cosmic cartographer's kit was the redshift survey. When light travels from distant galaxies, it carries with it the imprint of speed and distance. Due to the universe's expansion, as described by Hubble's law, the light from receding galaxies is stretched to longer, redder wavelengths. By measuring this redshift and comparing it with the galaxy's apparent brightness, astronomers could map not only distances, but also the rate at which the universe expanded. The first great surveys, such as the CFA Redshift survey in the late 20th century, began to reveal the large-scale structure of the cosmos. Galaxies arranged in filaments and walls, vast voids in between, a cosmic web spun over billions of light-years. This web was not random, but hinted at the initial conditions of the universe, the seeds planted by quantum fluctuations in the earliest moments after the Big Bang. Still, the ultimate map lay not in the distribution of galaxies, but in the faint afterglow of creation itself, the cosmic microwave background, or CMB. Discovered by accident in 1964 by Arno Penzias and Robert Wilson, who were searching for sources of interference in a radio antenna, the CMB is the oldest light we can see, released when the universe was a mere 380,000 years old. It is a near-uniform glow, but with tiny fluctuations, hot and cold spots, imprinted by the density variations that would one day form galaxies and clusters. To measure these subtle differences required instruments of exquisite sensitivity. The COBE satellite, launched in 1989, mapped the CMB with sufficient resolution to confirm its uniformity and detect its tiny ripples. The successor, WMAP, and later the Planck satellite, improved this map to breathtaking precision. The pattern of fluctuations in the CMB encodes the universe's geometry. In a flat universe, the hot and cold spots would appear at a certain characteristic angular scale. In a curved universe, they would be subtly larger or smaller. The data from Planck, rendered as a map of the whole sky, allowed cosmologists to measure the curvature of the universe with astonishing accuracy. The result, to within a tiny margin of error, the universe is flat, not closed like a sphere, nor open like a saddle, but with geometry that stretches, uncurved, across the observable cosmos. But the tools of cosmic cartography do not end with telescopes and satellites. They include the mathematics of topology and geometry, the computer simulations that recreate the growth of structure, and the particle detectors that seek the ghostly neutrinos and elusive dark matter that sculpt the universe's fate. In laboratories deep underground, scientists build detectors shielded from cosmic rays and noise, hoping to catch the faint signals of particles that may reveal new aspects of the universe's composition. The Gran Sasso Laboratory in Italy, the Sudbury Neutrino Observatory in Canada, these are among the silent sentinels, waiting for the briefest whisper from the cosmos. Each detection, each rare event, adds a new contour to our map. On mountaintops, arrays of radio dishes and optical telescopes work in concert, watching for brief flashes and bursts, fast radio bursts, supernovae, and the subtle lensing of light by intervening mass. Gravitational lensing, predicted by Einstein, allows astronomers to see the bending of light by massive clusters, the warping of space itself. By measuring how background galaxies are distorted, we can trace the invisible scaffolding of dark matter, the web that underlies the visible universe. And now, a new messenger has joined the cosmic dialogue. Gravitational waves, ripples in space-time itself, detected by LIGO and Virgo. When black holes collide, the resulting waves wash across the universe, carrying information not just about their sources, but about the very fabric of space-time. With each detection, the three-dimensional map of the cosmos grows richer, more detailed. The mathematics of topology provides another set of tools, less tangible, but no less vital. If the universe is finite but unbounded, like the surface of a torus or donut, it might wrap around on itself. The same galaxy might appear in different places on the sky, seen along multiple paths. Mathematicians and cosmologists work together to search for matching patterns in the CMB, circles in the sky, that might reveal a multiply-connected cosmos. So far, no clear evidence has emerged, but the search continues as new instruments extend our reach. The universe's expansion, too, is measured with ever more subtle tools. Type Ia supernovae, once thought to be standard candles, revealed a new surprise. The expansion is accelerating, driven by a mysterious, dark energy. Teams of astronomers scan the skies for these stellar explosions, measuring their brightness and redshift to trace the changing rate of cosmic growth. The discovery, announced in the late 1990s, transformed our understanding of the universe's fate and added new layers to our cosmic maps. Supercomputers, humming in darkened rooms, now simulate the evolution of the universe from its earliest moments. Starting with the laws of physics and the initial conditions inferred from the CMB, these digital universes grow galaxies, clusters, and voids, allowing us to compare theory with observation. The Millennium Simulation, the Illustris project. These are the laboratories where virtual universes are born, tested, and refined. In the end, the tools of cosmic cartography are as varied as our imagination. Telescopes that catch visible light, radio waves, X-rays, and gamma rays, satellites that map the sky in exquisite detail, detectors buried deep to shield from noise, the minds that devise algorithms and the hands that build instruments, and the patience to wait for signals that may come once in a lifetime. Through all these means, we have learned to read the geometry of the cosmos, to measure its curvature, its expansion, its hidden mass and energy. Yet each answer spawns new questions. Is the universe truly infinite or merely vast beyond our reach? Are there hidden dimensions, subtle curvatures or connections we have yet to detect? Do the patterns we see repeat, echoing around the cosmic horizon, or is each region unique, forever out of sight from all others? As we lie beneath the quiet sweep of the stars, we can sense the gentle hum of these instruments, the silent work of photons gathered and sorted, the faint tremor of gravitational waves nudging detectors, the digital universes swirling in memory. The map grows ever more detailed, yet the landscape always recedes, inviting us onward. Tonight, our journey pauses at the edge of discovery, among the whirring machines and silent sentinels, the patterns etched in ancient light. The tools of cosmic cartography have brought us far, but the next horizon always beckons, a new experiment, a fainter signal, a pattern just beyond the reach of our current maps, waiting for the next generation of explorers to trace its outline in the deepening dark. The night is deep, and the universe, as always, is wider than our dreams. The faintest glimmer of starlight, filtered through the eons and the emptiness, settles softly on your eyelids as you lay adrift in the gentle currents of thought. We have travelled far in our exploration, from the first trembling hints of cosmic geometry through the scaffolding of space and time itself. And now, in this quiet hour, we find ourselves poised at the threshold of wonder, a moment to gaze not just outward into the vault of the cosmos, but inward at our own reflection in its endless dark. For when we speak of the shape of the universe, we are not merely mapping the heavens with the cold tools of mathematics and measurement. No, we are also tracing the outline of a mystery that loops back upon us, teasing at the very core of our being. Each equation etched on a blackboard, each telescope turned skyward, is a gesture of longing, a yearning to understand not only where we are, but what it means to be here at all. Consider now the unfathomable scale of the universe. In the silence of deep space, there are distances so vast that they defeat all ordinary language. Light, that swiftest of cosmic messengers, takes millions, even billions of years to cross the yawning gulfs between galaxies. The shape of the universe, whether flat, closed or open, is drawn out across unimaginable reaches, a tapestry woven from the fabric of space-time itself. Yet, for all its grandeur, this shape is not some remote abstraction, but the very container of our existence, the stage upon which all our stories unfold. This is the paradox at the heart of cosmic inquiry, that the universe is at once terrifyingly indifferent and intimately connected to us. The atoms that make up your body were forged in the hearts of ancient stars, scattered across the void and gathered by the slow choreography of gravity and chance. The very laws that govern the curving of space-time, the expansion of the cosmos, are the same laws that guide the falling of an apple, the flutter of a heartbeat, the arc of a thought. So, as we peer into the depths, asking after the universe's ultimate architecture, we are also asking about ourselves. What is our place in this immensity? Are we fleeting motes adrift in a purposeless expanse, or participants in a story whose meaning is written in the very shape of the cosmos? Let your mind drift with me then to the earliest dawns of human curiosity. Long before the invention of the telescope, ancient peoples gazed upward, pondering the dome of the sky, the cycles of the stars, and the turning of the seasons. Their myths and legends, inscribed on stone and sung around fires, were the first attempts to make sense of the cosmic order. The shape of the world, whether imagined as a disk floating on water, a mountain-ringed plain, or a celestial sphere, was always bound up with questions of meaning and purpose. Thousands of years later, the tools have changed, but the yearning remains. Modern cosmology, with its satellites and supercomputers, still seeks the answer to a question as old as humanity. How does it all hang together? What lies beyond the edge of sight? In the cold data of the cosmic microwave background, in the subtle distortion of distant galaxies, we search for clues to the universe's ultimate design. Is space infinite, or does it curve back on itself in some unfathomable loop? Is time a straight arrow or a circle, or something stranger still? Somewhere in the symphony of evidence, echoes of ancient wonder persist. The mathematics of general relativity, with its elegant curvatures, is not so far removed from the poetic visions of our ancestors. Both are attempts to describe something ineffable, the way the universe folds around itself, the way it gives rise to pattern and structure, to beauty and surprise. And yet, as we map the heavens, we encounter not certainty, but mystery. The observable universe, vast as it is, may be only a minuscule region of a much greater whole. Beyond the cosmic horizon, where light can never reach us, the shape of space could twist and turn in ways we cannot imagine. Perhaps the universe is infinite, stretching endlessly in all directions, or perhaps it is finite but unbounded, like the surface of a sphere, a place where you can travel forever and never find an edge. Perhaps there are many universes, each with its own laws, its own geometry, its own music. This uncertainty is not a failing, but a gift. The universe does not yield up all its secrets. Instead, it invites us to wonder, to question, to reach beyond the limits of what we know. In the spaces between knowledge and mystery, science becomes an act of reverence, a way of paying homage to the grandeur and subtlety of the cosmos. Yet, for all its remoteness, the shape of the universe is intimately entwined with our own fate. The geometry of space determines not only the paths of galaxies, but the possibility of life itself. If the universe were curved too sharply, it might have collapsed back upon itself before stars and planets could form. If it were too diffuse, matter might never have coalesced into the intricate structures we see, galaxies, solar systems, living worlds. The existence of beings capable of pondering the universe's shape is, in itself, a miracle of cosmic balance. Pause for a moment and feel the quiet weight of this realization. You are a part of the universe, an expression of its laws, a ripple in its vast ocean. The atoms in your bones, the thoughts in your mind, are woven from the same cosmic fabric as the galaxies and the void. To seek the shape of the universe is, in a sense, to seek ourselves, to trace the outlines of our own story written in the language of stars and space. And what of meaning? Does the universe, in its immensity, offer up any answer to the questions we carry in our hearts? The great thinkers of ages past have wrestled with this riddle. Some have seen in the order of the cosmos a reflection of divine purpose, a harmony that points beyond itself. Others have found meaning in the very act of seeking, in the courage to confront the unknown and to find beauty in the mystery. Perhaps in the end, the meaning of the universe is not a secret hidden in its shape, but a song that arises from our engagement with it. The universe is not mute. It speaks in the language of light and gravity, of pattern and chance. We, in turn, respond with curiosity, with awe, with the slow accumulation of understanding, and with the stories we tell each other in the dark. Let your thoughts wander now along the great arc of human discovery. From the ancient astronomers of Babylon to the mathematicians of Alexandria, from the medieval scholars who mapped the spheres to the physicists of our own age, each generation has added a thread to the tapestry of cosmic understanding. The questions have grown more precise, the answers more subtle, but the underlying impulse remains unchanged, to glimpse the structure of the world and to find our place within it. In the present moment, we stand on the shoulders of giants, peering ever farther into the night. The cosmic microwave background, that faint afterglow of the Big Bang, whispers to us of beginnings. The distribution of galaxies, spread like jewels across the void, hints at the invisible scaffolding of dark matter and dark energy. The equations of relativity and quantum mechanics, strange and beautiful, suggest that reality is deeper and stranger than we can comprehend. Yet, for all our progress, the greatest mysteries remain. What is the true shape of the cosmos? Is it finite or infinite, simple or complex, singular or plural? What lies beyond the reach of our instruments, our equations, our dreams? These are questions without final answers, questions that invite us to keep searching, to keep wondering, to keep unfolding the cosmic mystery. As you drift, imagine the universe as a vast, unfinished poem, a work in progress, with each of us adding our own lines, our own verses, our own quiet hopes. The shape of the universe is not merely a matter of geometry, but of poetry, of imagination, of longing. To ponder it is to participate in an ancient dialogue stretching across the centuries, linking us to those who came before and to those who will come after. In this gentle darkness, as the world outside grows still, let yourself feel the wonder of it all. The universe is wide, and you are small, but you are also vast in your own way, a bearer of consciousness, a spark of curiosity, a witness to the unfolding mystery. The shape of the cosmos is not fixed. It is alive, evolving, growing with each new discovery, each new question. We are not apart from it, but a part of it, a way for the universe to know itself, to gaze into its own depths, to marvel at its own reflection. Somewhere, in the silence between stars, the mystery endures. It beckons us onward, ever deeper into the unknown, ever closer to the heart of wonder. The universe may never yield up all its secrets, but it offers us something greater, the invitation to seek, to dream, to be astonished. In the quiet of this night, as you close your eyes and let your thoughts drift outward, remember that you are a child of the cosmos, a wanderer in the infinite, a questioner of mysteries, a bearer of the ancient flame. The shape of the universe is written in your bones, in your breath, in the endless unfolding of your own story. And so, as the stars wheel overhead and the darkness deepens, let yourself rest in the embrace of the unknown. The cosmic mystery unfolds, and you, small, fragile, luminous, are part of its eternal song. As our journey through the shape of the universe gently drifts to a close, like a comet tail fading into the hush of space, may your thoughts wander softly among the stars. Rest peacefully beneath the vast cosmic canopy, and when you're ready, return with me for more Dreamtime tales that illuminate the quiet mysteries of our boundless sky.